The ocean absorbs carbon dioxide from the atmosphere, acting as a natural carbon sink. This is a natural process that has been occurring for millions of years. However, human activities have significantly increased carbon dioxide levels in the atmosphere. Burning fossil fuels such as coal, oil, and natural gas is a major contributor to this increase. As the ocean absorbs more carbon dioxide, it becomes more acidic, altering its chemistry. This phenomenon is known as ocean acidification. Ocean acidification is a gradual process, but its effects are far-reaching. It is having significant impacts on marine ecosystems, affecting coral reefs and marine life. The pH of the ocean has already decreased by 0.1 units since the pre-industrial era, a notable change. This may seem like a small change, but it has profound implications. It represents a 30% increase in acidity, which is alarming. The ocean is becoming more acidic at an alarming rate, faster than ever before. This is due to the increasing amount of carbon dioxide being released into the atmosphere from various sources. The ocean's ability to absorb carbon dioxide is being overwhelmed, leading to dire consequences for marine life and ecosystems. Scientists are carefully monitoring the pH of the ocean. They use sophisticated instruments to track changes over time. The data clearly shows a trend of decreasing pH. This indicates increasing acidity. The most significant changes are occurring in certain regions. These include the North Pacific and the Arctic Ocean. These areas are particularly vulnerable to ocean acidification. This is due to a combination of factors, such as cold water temperatures and ocean currents. Ocean acidification is not just a theory, it is a measurable phenomenon. It is happening now, and it is accelerating. The scientific evidence is overwhelming. Ocean acidification affects marine organisms in different ways, creating both winners and losers in the marine ecosystem. Some species are more sensitive to changes in pH than others, struggling to survive in increasingly acidic waters. Organisms with calcium carbonate shells or skeletons are particularly vulnerable, as the acidic conditions dissolve their protective layers. This includes corals, shellfish, and some plankton species, which are essential to the marine food web. As the ocean becomes more acidic, it becomes more difficult for these organisms to build and maintain their shells, leading to structural weaknesses. This can lead to reduced growth rates, weakened shells, and increased susceptibility to disease, making survival even more challenging. The impacts of ocean acidification cascade throughout the food web, affecting not just individual species, but entire marine communities. As keystone species like corals and plankton decline, it affects the entire ecosystem, disrupting the balance of marine life. This can have profound implications for fisheries and the livelihoods of people who depend on them, threatening food security and economic stability in coastal regions. Section 4, Beyond the Waves, Ocean Acidification in Human Society. Ocean acidification is not just an environmental problem, it is also a societal one. The impacts on marine ecosystems have far-reaching consequences for human communities. Many coastal communities rely on fishing and tourism for their livelihoods. These industries are threatened by the impacts of ocean acidification on marine life. Reduced fish stocks and damaged coral reefs can lead to economic hardship. Ocean acidification also has implications for food security. Millions of people around the world depend on seafood as a primary source of protein. As ocean acidification reduces fish populations, it could exacerbate food shortages. Section 5. Turning the tide. Our collective responsibility. Addressing ocean acidification requires a global effort. Nations must come together to create and enforce policies that reduce carbon emissions and protect marine environments. Reducing carbon dioxide emissions is crucial. Industrial activities and urban development contribute significantly to the problem, and we must find sustainable alternatives. This can be achieved through a transition to renewable energy sources and increased energy efficiency. Investing in wind, solar, and other renewable technologies is essential. Protecting and restoring coastal habitats, such as mangroves, is another vital step. These ecosystems provide natural barriers against climate change impacts. And seagrass beds can also help mitigate ocean acidification. These underwater meadows are crucial for maintaining marine biodiversity. These habitats act as carbon sinks. Absorbing carbon dioxide from the atmosphere, they play a significant role in regulating our planet's climate. Raising awareness about ocean acidification is essential. Communities must be informed and engaged in conservation efforts. Educating the public about the issue and its impacts can encourage individual and collective action. Schools, universities, and local organizations play a key role in this. We must act now to protect our oceans from further acidification. Every small action counts, from reducing plastic use to supporting clean energy initiatives. The future of marine life and our own well-being depends on it. Together, we can turn the tide and ensure a healthier planet for generations to come.